Now I just want to talk about the most important things in whole econometries and statistical arbitrage as well as hedging. It is causal inference, and I talk about examples in Forex and CFD. Before I begin, I just introduce four great books for causal inference. So our job is just to discover these unit-directed graphs, find the relationship between GBP USD, Euro USD, USD CHF. So we start to choose either we take the treatment, drug treatment, or we should be considered in control group. So Joe or Mary has to take either a drug or be considered inside control group. The problem is Mary, for example, Mary cannot choose drug treatment and control group at the same time. So we have some unobserved data, some missing data, and this is the philosophical problem of causal inference. For example, in Forex, if GBP/USD has an effect on Euro/USD, we can measure it in terms of pips, and if we don't take that active treatment, we are considered a control treatment. The basic assumption is stable unit treatment value assumption. And so what is assignment mechanism? How is it determined which units get which treatments, or equivalently which potential outcomes are realized and which are not? We have different kinds of assignments. One is probabilistic, the other one individualistic, and the last one unconfounded. Another example in Forex, we have different units. In biomedical engineering or health or these, for example, social science, the units are people. But in Forex market, we have different financial market situations, and these are our units. So different outcomes. Potential outcomes are 1 by I of 1. It means that we take the treatment. 0 is that we are in the control group. So our job is to see the causal effect, the difference between these potential outcomes. So we can measure the intensity of Euro/USD candle size before making the decision to take GBP/USD or not. We defined causal estimates, and X is covariates. For example, age. It's a pre-treatment variable. W is treatment assignment. For example, what kind of treatment you decide to choose. As I said, we have different methods for assignment. And covariates, there are different examples for covariates in Forex market. For example, oil is in bear market and it is decreased how many pips in its one candle. Coronavirus effect on market as a number. So these are covariates. I call pre-treatment variables before observation, before experiments. And these are very typical definitions in these books that I introduced. So the most important things is propensity score and so Fisher has an idea that says a very strong null hypothesis, very strong saying that under the null hypothesis, all potential outcomes are known. For example, if Joe takes the treatment and he has a potential outcome of 4, then if he didn't take the assignment, didn't take the treatment, then he could have the same value. And so our null hypothesis is the equality of these potential outcomes. So we have to decide because it's just a statistical test. We have different statistical tests such as t-tests, such as rank statistics. And if you want to your data not become so sensitive to skewness of your distribution, use a logarithmic transformation. And for example, if you don't want your data to be sensitive to outliers, use median. So we have different test statistics, and we understand how likely those sample groups are. So there is a very minor difference between Nyman and Fisher, as you see. Nyman, for example, the null hypothesis of Nyman says average treatment effect is 0. But Fisher is very strict. He says no treatment effect at all. And there is an alternative, regression analysis. So Fisher and Nyman, they both say that potential outcomes is fixed. We fix the potential outcomes. And the treatment assignment is the only source of randomness. But in regression analysis, even if you fix some assignment, you still have the volatility, the the problem of unobserved data. So there is no deterministic value. So it's just a scatter of data in regression analysis. Both of these methods have their own pros and cons. So we create a linear regression between potential outcomes that we have observed to the assignment variable, which is W. And for example, if your x-axis is assignment vector, is assignment, you increase the assignment, and you see the effect of that on potential outcome. The interesting thing is, if you solve this regression problem, this simple linear least square problem, you come up to this result that shows that in this case the ordinary least square estimator is identical to the difference in average outcomes by treatment status. And you can also add your covariates variable, which is x, and have a better solution.